Hello and welcome to Func Prog Sweden. We are back finally. First, I would like to welcome all new participants to Func Prog Sweden. Welcome. This is the meetup where we explore functional concepts and functional programming languages like Clojure, Erlang, Haskell, Elixir, and more. And also like to welcome all recurring viewers. Welcome back to Func Prog Sweden. Thanks for coming back to us and watching us again. With that, we'll look over to the agenda. So today's agenda, as always, I'll do a short intro by me, Magnus Sedlacek. And then we will hear a presentation called Witchcraft, Lessons from Porting Monads to Elixir by Brooklyn Zelenka. Brooklyn is a distributed systems researcher and editor of the UCAN auth spec. She founded the Vancouver Functional Programming Meetup and has worked on standards spanning distributed virtual machines, data privacy, databases, wire formats, key agreements, and others. And then when Brooklyn is done, we'll have over to painless, stretchy web apps using shorthand notation by Edward de Jong. Edward is an old-timer. He's been around for a long time. He started programming in high school in Pasadena, in California, on an IBM 1620 punch card laptop, or not laptop, maybe it was like a mainframe. Later used the UNIVAC 1108 JPL on the IBM Systems 370 at Caltech, and then graduated from MIT with a bachelor's degree. He progressed to HP, mini computers, then IBM, and then Apple Macintosh, personal computers, and finally mobile devices and the web. He was the lead programmer on WordStar 2000, IBM DisplayWrite 5 Composer, Flying Colors, Dragon Ball Z, Ultraman Paint program, and more, and currently has worked on over 90 iPhone web apps. Wrong way. Then in the end, we'll do a post-show chat on the Discord server, so if you want to ask more elaborate questions to the people presenting, please join the Discord server and take your opportunity to ask more questions. But first up, we would like to thank our video sponsor, Autobeat. Autobeat is an IT consultancy company working with functional programming, and if you want to know more about Autobeat, check them out on their webpage or on social media. And then the schedule for the coming meetups. In August, we are back. We haven't set a date, but we'll be back, and we'll have 1 or 2 presenters. Then 10th of September, we are running the next meetup, again live or on digital only. And then in October, we will be at Kivra in Stockholm. So if you are around in Stockholm in October, 8th of October, make sure to join at Kivra. And of course, you want to support the Func Prog Sweden community, head over to Meetup and join our group, or make sure to subscribe here on YouTube if you're watching. And of course, join the Discord server. You'll find the invite either in the Meetup page or on the YouTube spec, if you check below here. If you have questions during the presentation, please use the chat on YouTube or ask them on Discord, and I will convey them to the presenters, or join the Discord server afterwards, where you can ask more elaborate questions. With that, let's get started, and welcome to our first presenter, Brooklyn. Welcome to Func Prog Sweden.
Thank you so much for having me.
Yeah, you're warm welcome. We are very much looking forward to your presentation. So the stage is yours. Welcome.
Great. Awesome. Well, again, thank you so much for having me. I always enjoyed talking about, especially Witchcraft, especially this work, which in some ways shifted the course of my career. And we'll talk a little bit about how it came to be and some of the history here. But by accident, I haven't actually gone and dug through like the original commits, but this is, I believe, the 10-year anniversary of Witchcraft. So it seems like a good time to have a retrospective on the project. So I'm going to be talking about an Elixir, a suite of Elixir libraries together known as Witchcraft, and sort of the tagline for them is bringing Monads to Elixir. So there's this classic Perlis quote where he says that a language that doesn't change the way you think isn't worth learning. And that's true, but also, you know, sometimes we're not writing an entire language. Sometimes having a library change the way that you think can be helpful as well. And especially in functional programming, where there's not just one monolithic thing that is functional programming, there's all of these subdisciplines and that are ultimately compatible, but often a particular language will focus on one. And so without having to learn an entirely new syntax and an entirely new way of, you know, tooling and way of interacting, sometimes it's useful to change the way you think about things in a lighter weight way. So my name is Brooklyn Zelenka. You can find me most places on the internet as Xpeed. And as mentioned, I am an independent distributed systems researcher. These days I work a lot in an area known as local first. So computing where it's not local only, but by default, everything happens directly on your machine. And then if you need to go to the network to do synchronization or some heavier computation or something like that, then you can do that, which then often leads into a related peer-to-peer space. And lately been focused on, and this will actually become related at the very end, I think, end-to-end encryption capabilities, CRDTs, and virtual machines, especially WASM. And I wrote a bunch of Elixir libraries over the years. Sometimes people have called Witchcraft Haskell fan fiction, which is not inaccurate. So, but I've also written others that are less trying to bring things from this other ecosystem in. So Exceptional is probably the big one, which was bringing railroad exceptions. So almost like the either style, if you're familiar with those from Haskell and some other languages, before Elixir had the with syntax, which we'll probably touch on a little bit later. And frankly, I had a ton of fun writing these libraries. Yes, I founded the Vancouver Functional Programming Meetup, ran that basically until the pandemic hit. It was in person. And that went from, maybe about 2012 to 2020, and we should probably get that started again. So maybe this will be my inspiration to get that going again. So what is Witchcraft? So I started learning, I became aware of Elixir probably around 2013 or so. Prior to that, actually my first programming job, the first language I learned was Clojure, and then Scala and a few others, as well as a bunch of imperative languages. And became aware of Elixir around 2013. And Vancouver has a lot of Rubyists, and thus Elixir appealed to them. And so we had a lot of people suddenly showing up to the functional programming meetup asking, hey, can we learn Elixir? So I thought, okay, sure, you know, let's take a look at this thing. And coming from, especially coming from Haskell, but to a lesser degree Clojure, Elixir didn't feel very functional to me. It had the immutability and the purity, but it didn't have a lot of the patterns that I was otherwise used to. And if you dig into the history of Elixir, this makes a lot of sense, right? They didn't even set out, so Elixir and Erlang are very famous for having this actor model for high concurrency. And they didn't even really set up to create something based on the actor model. They were just trying to solve problems at Ericsson. And they happened to stumble on something that looked a lot like the actor model, and they found out that that's what it was later. And so same thing with functional programming. They didn't set out to create a functional language. They just happened to fall into this functional-ish flavored thing. I figured we can fix that. So a lot of people were showing up. They wanted to learn Elixir. They wanted to learn Haskell idioms. What if we could blend the two with a language that felt at least safer to learn for especially Rubyists? And I've always found this to be like a deep irony, because Elixir has other than some high-level syntactical things, has very little to do with Ruby, like at all. But Rubyists seem to like it because it comes from this. A bunch of people that started on Elixir were from the Ruby community. So I figured, how hard could it be? And it turns out that it's a lot of fun, but a lot of work, So 5 libraries in this suite. The first one that we wrote was Quark, which was trying to show like the really classic FP stuff. And we'll talk about this a little bit more in a moment. But yeah, it ended up being 5 libraries instead of one giant monolithic thing, because they actually turned out to be pretty useful on their own in multiple contexts. So there are also some challenges in doing this versus, like, especially, we're going to talk a lot about Haskell here, obviously, right? So Haskell as a language and a runtime has certain guarantees about how it works, right? Its type system works in a particular way. It gives you a lot of safety. That, the classic line is, some addition operation won't fire the missiles, right? And you don't get that in Elixir, right? It's heavily side effectful. You're always calling between actors. It's very low on equational reasoning unless you're doing like really constrained things. It's simply typed. It has some bolt-on analysis with some extra tools, there's dialyzer, etc. But it doesn't really have something like deeply ingrained. They are working on a type system right now using set theoretic types, which is a newer type system coming out of academia. That's super interesting, but I don't believe it's actually shipped fully yet into the language. And at the time that I was writing this, they didn't even have support for things like automatic threading of errors. They now have a syntax called with syntax that has left pointing arrows and actually looks pretty much like denotation, only for exception or for error handling. So as I mentioned, this was for also people wanting to learn sort of both. So I started Quark. So it's called Quark because it's about the small independent things that come together. So the basic combinators like identity, SNK, fixed points, composition. So Elixir doesn't have a composition function, or at least not at the time. I think they still don't. They only do application. Started that around 2014. Bulk of the code and through most of these projects would have been about 2015. Quark saw production use from basically day one. So I got to use it directly in my job. So I was writing Elixir professionally starting about 2015. Yeah, early 2015. And it was just broadly useful. So being able to stub out arguments with identity, for example, is a really common thing. Being able to flip the order of arguments without having to write a new variant, pretty helpful. Things like that. And then in the wider set of libraries, I found out a few years later that apparently not really supposed to say who, but a large bank started using it in their trading platform, Witchcraft. So like the full with Monads and everything, which was a surprise to me because it started out really just as this like exploratory project that's mainly for teaching purposes. And then it ended up getting a lot of production, way more production use than I expected. So it's certainly not as popular as the web framework Phoenix or something, but a lot of people seem to want to write code in this way, even in other languages. As a general strategy, so I've seen a lot of these attempts to port from one language to another, and they're not always successful, right? Because they try to take really that way of thinking, so like that perilous quote from the beginning, and just apply them and impose them directly on the new host language. And it ends up feeling like these disconnected pieces that are not unified with the rest of the ecosystem. So having something that feels, even though it has these new idioms and these new ways of working, these ways that feel more like that host language was the strategy from day one. So how can we make this still feel like Elixir? How do we use the pipe operator to thread through arguments? So they have this, it looks like a little arrow that you then pipe through. The argument order is different than in Haskell. You're not mapping, often the mental model changes, right? In Haskell, you have a function that you map with an operator over some arguments. But you don't do that in Elixir. You pipe arguments through functions, right? So you have to rethink and sort of like pull apart your understanding of these guest idioms into the host language, and then reinterpret them for it. There were a bunch of just straight up missing features in Elixir for this style. So they have protocols, which are basically type classes, but without constraints on them. So you can create a protocol for a particular, let's say you want a functor, you get a functor, but monad depends on functor. They had no way of expressing that. So we had to port that into the language. Luckily, Elixir, for better or worse, better for me, maybe worse for them, has macros. And so you can basically, plug into the compiler and extend it as much as you like. And as an approach, we wanted to start small. So, adding a compose function and then grow those features out into the really, the intense things. So having arrows and fan outs and all of these things. I actually think that the arrow stuff was criminally underused in Witchcraft, because it seems like such, there's so much data flow stuff that happens inside of in Elixir, and this gives you a really concise way, a really crisp way of expressing those data flow operations that wouldn't depend on a particular library like or a particular implementation. So they have all of these data flow libraries that are even shipped by the core team. And so this would give you an abstraction over those. And yeah, so we use functions whenever possible. We heavily abuse macros, and made sure that we wrote our macros as functions and then called those functions inside of macros so that we could test them easily. And we worked with raw AST, not with the declarative macros. It was all Prog macros all the way through. The hard one for all of this is having a consistency with mental models. And a lot of that is how you actually express from the language level. And we'll look at some specific examples of this. And we wanted it, and we in fact tested along the way that we could use these with other languages, with other libraries in the ecosystem. And then it was obviously also focused around pedagogy, so teaching and approachability. So the docs had to be nice. They had to teach the concepts. They had to have examples and doc tests and all of these things. So it was almost like the docs aimed almost to be like a little mini lesson on these concepts at the same time, with, I would say, varying degrees of success. These all depend on each other. Quark at the bottom, we have operator, TypeClass, Algae, and Witchcraft at the top, consuming all of them. So Quark, as I mentioned, has all of your basic combinators, so SK and I. So even with just S and K, you can get all of functional programming, fixed points, various fixed points, automatic partial applications. We created some macros so that you could write def partial as opposed to def for your function, and it would automatically generate all of your partial applications. So Elixir is a variadic language, so you can have the same named function have multiple different numbers of arguments in it. And so this would generate functions that would return functions with a partial application in it. So with one of the arguments already pre-applied. Identity, flip, constants, etc. And I don't know how I really feel about point-free programming. So this is using only the composition operator. So you see this in Haskell, and is sometimes very, very elegant, sometimes difficult to debug. But we created a point-free operator. We'll talk a little bit about operators in a moment. And this was very broadly useful. We ended up using this inside of that other error handling library that's not in this monadic style at all, called Exceptional. I've seen this one because it just has the basics in it in a lot more projects than a lot of the other pieces. Operator, this is just a little utility library that we lean on pretty heavily inside of Witchcraft. Elixir chose to have a fixed number of operators, regardless if they're infix or prefix or the various fixities. They have this particular list and none others. And binding those two functions can be a little cumbersome. Like they don't really want you doing it, right? Unless you really, really have to. And that's fair, I think, right? Like we've seen in the Haskell ecosystem over time, people moving away from these operators. If you've ever looked at the lens library in Haskell, it does produce this really interesting mental model where you know what all of the different sigils mean now, but they don't, you really have to learn this really specific DSL now, right? So they give you a constrained set of them. I would say that the best decision that we made in operator is that you must have a named function, which Elixir doesn't enforce, right? So you must have a named function. And then you can just with an annotation above it, you go at operator, and then you say which operator it's bound to. And then it just generates the rest for you at compile time. Pipes, so again, Elixir has this pipe operator. I would say that that's the preferred way of doing things. Pipes are the best way of doing, of having something that's closer to an infix, because it is an infix, right? So you're always doing this piping through. There definitely are times when you want these other things, right? So we're going to talk about how we brought do notation into Elixir, like full-on Haskell style do notation, requires some of these, right? So sometimes it is helpful to have them still. Algae, so these are for algebraic data types, which Elixir doesn't have. It only has structs. So basically maps with a set number of keys in them, and actually under the hood, they're just structs with a special key that says, hey, this is a struct, like, you know, maybe don't only allow us to set certain fields on it, but you can actually work around that if you need to. It doesn't give you co-products. So there's no way of unioning two things together. So because it's a dynamically typed language, right, or very, very simply typed, they tend to rely on things like this in the top right, where you have you know, some symbol like just, and then some value or error. You'll see this all the time as error handling, but there's nothing preventing you from having any number of these tuples, right? And I've actually run into this as a major problem. There was like actually a blocker for me for a long time with some undocumented edge cases like this. Because you don't have strong typing, they can use whatever they feel like, any number of arities, you know, all of this stuff. And so having something that's a little bit more constrained where you can say, well, my options are just or nothing, and those are always structs, means that if I need to add more fields later, I can. It's extensible in a way that having a tuple isn't. You add another field to a tuple, your pattern matches fail. If you do it with a struct, you don't have that problem, right? I think this is the most broadly useful, despite Quark probably getting more, me seeing it in more places. I actually think this is the broadest one that I would like to see happen in more places, other than they're bringing, again, this set theoretic types to Elixir now may just solve this. But being able to, and we'll look at some nesting examples later of how this really helps the style in Elixir in general, beyond thinking about functors and monads, right? It doesn't require you to change the style or idioms at all. This is entirely about data and how data relates to each other. Okay. So this is with Algae, how you would define a maybe, or sometimes called an optional. So you have your module here. This is the directly out of the code, because we shipped a bunch of common data types in the library. So this is algae.maybe. We use quark.partial for our partial application in it, so that's an import. And then we include these types. So it's either just.t, which is how in Elixir you typically call the type of a single type in a module just t, so just or nothing. And then we have these two modules, nothing, that has this struct inside of it, so def struct, has these square brackets, and then just has this one case. This is how you would This is the implementation, not the macro that defines it, which we'll look at in a couple of slides. But this is what it generates out at the other end. TypeClass. So as I mentioned before, protocols in Elixir are basically type classes that, or an interface that only you just define the one interface for it. They also have this thing called behaviors. It's a related concept, but we went with protocols because they're much closer to type classes. And I think possibly we took macros further than I've seen any other project do, at least definitely at the time. Maybe there's some more intense stuff now, but the macro code in this stuff is intense, right? So in general, the first rule of Macro Club, don't use macros, right? Unless you really have to. And we looked at it and we're like, yeah, we really do want these features. So we went pretty far with it. Type classes, even in a language like Haskell, can be unprincipled, right? So they might not have laws associated with them. So if you have something like a monoid, so this is a construction where you say, I have, let's say numbers, and I can add them together. So that's my monoid, and I can always add more of them together. The law there is that there's, it's associative, it's commutative, right? I can understand algebraically how this thing should behave. There's nothing about type classes that enforce that. So we thought, what if we added that to type class so you could then describe your the properties that you expect it to have, and it'll complain at you if you have no properties, but you can then still tell it like, I'm just going to skip this, but like by default it'll complain. And then it'll automatically test them, it'll prop test them on all of your implementations. Some of this was a mistake, and I'll tell you specifically why when we get to some of the lessons later. But the overall idea of having protocols that can depend on protocols is a good idea. And in fact, I would like to see it in more places. This is how type classes work. This is how traits work in languages like Rust. It was actually really surprising to me that it wasn't in there originally. Around, maybe 2017 or so. So all of this stuff now is like pretty stable. The company that I was working at, running Elixir at the time, had outsourced an Elixir project to an external team that had never used Elixir before. And it was like months behind using Phoenix, the main web library. And so they called me in to like fix it as fast as I could. And I pulled in TypeClass and actually had it working in like days. Now, would I recommend actually doing that? No, the library author, using their own tools to do this, but we were able to like really just enforce, hey, each of these controllers in the MVC needs to have exactly these things. And I'm just going to describe it with a type at the top, and it's going to generate for me all of the data types and all of the, enforce that it has tables that, work this way and all of this stuff. And we could have this class inheritance. And by class inheritance, I mean like a type class style inheritance. So there's super types, not subtypes, to manage all of that. It was actually, I don't know if I'd want to maintain that code, but it got us up and running really fast and shipping things out the door that we could then put into a more standard idiomatic style over time. So this is example. The top is what actually gets like a basic protocol, right? So this is the standard protocol thing for applicative. And then the bottom is how you would implement that, again, the standard way in Elixir, right? So we're generating all of this stuff out, basically, using TypeClass. The only code that you're required then to write is this, just a couple small functions, and then the rest of it automatically gets generated for you using all the macros. So these are the properties that I was mentioning before. So in when you're writing a type class, you want to have all of these, and we call them spot check identity because we're going to then prop test them at the end. So in this case, we have identity composition, homomorphism, interchange, and functor as well on this one. And so it just automatically uses the implementations that come from the imported or from the constraints, because we know that we have them around now. You don't have to re-implement all of these things all the time. You know that you have a type that already has an implementation of this other thing. You can just keep using them. Hopping back to Algae, so looking again a little bit more at like what do these interfaces actually look like. So in Algae, we had def data and def sum, as opposed to def struct, which is the default. And this let us put types directly in the definition, and we could list them out in this more linear way rather than in the standard way. You basically say, hey, there's a bunch of keys and they look like this, and that's just in a list. Here we can say, yeah, I have name, so this is like for a character, clearly, in like a video game, name, hit points, experience, and they have these types on them. And we're using that double colon, which is like what Haskell has, right? You have this double colon syntax. Def sum lets you put together a bunch of these def datas. And we went relatively far with this, where there's a bunch of different variations so that you don't always have to crack open a do block. So if you see on the bottom, it's just a single line for each def data, so that you don't have to now have like multiple lines for each option in the sum. You can just list out a whole bunch of variants directly there. And then this one small block, which is 4 lines, including the end, generates out all of that code that I was mentioning before. So you get all of this stuff. You even get constructors out of it. So they have a new function, and generates the types for you, all of this stuff. You can even have it, it's not shown here, but you can also have it generate default values in your new. So you can put, I think it's, equals, no, sorry, // and you can put a default value if you want to have defaults in it. And then, so this is the classic maybe. So you can import in just a nothing. You do have to import them directly, so unless you want to have an import macro. And they work as you would expect, right? So now you can have this this add function that can fail into a nothing, and there we go. Adding 1 and the wrong type fails us over into nothing, right? Instead of having the try block on the left there, blow the stack. You can blow out of the unwinding the stack by throwing an error. Witchcraft, I would say, is the main show. In Elixir, you're really trapped in the IO monad all the time. There's no way to enforce purity because you're always, talking between actors, very side effect focused. Because it's such an async focused language, we didn't want people to have to always wrap things in tasks so that they would asyncify. So we just shipped variants. So we had map and async map. And there was also some subtleties around how you would want to wrap the task to make it more performant. And so we just shipped those as part of the library. So Witchcraft is what gives you actually like functors, monads, applicatives, and we'll look at that whole hierarchy in a moment. And we want to think about it like we're implicitly in IO all the time. So you're not again, for the Haskells out there, you're not doing map, you're doing map M constantly, right? And there's a lot of differences in here from Haskell. Again, we had to sort of take the concepts apart, really understand them. So it's a good way of making sure that your understanding of Haskell is in depth too, and then recombine them in this more Elixir-y way. So as you see some of the code, some of it will look familiar if you come from Haskell, some of it will look less familiar as well, especially the piping order. So in Haskell, when you do application, it applies to the very end because of how the $sign works. In Elixir with the pipe, it ends up as the first argument. So, and in a lot of cases, that ends up being really awkward, and we wanted variants that were like renamed about where you're piping into. So actually the Haskell way is significantly more consistent it is. So we want to be consistent with the local language. What we don't want people to feel is this, you know, I mean, it's in the name, witchcraft, right? It should feel natural. You're doing functional programming in a functional language. This should all feel like a natural extension, right? People understand maps because they have enum.map in Elixir. They should understand functor.map. And in fact, functor.map should be even more convenient. There's some stuff about enum.map that I don't love. Like it always outputs a list at the end. I want to get back to the original data type that I was in without having to track manually, you know, what order my binary tree was sitting in or something, and then reconstructing it. This is something that drives me, I write a lot of Rust these days, drives me wild in Rust too. So this is an example of making, trying to plug into the intuitions and Elixir, and sometimes they're called alchemists, that an alchemist would have. So I have this anonymous function on the left side, and then I'm piping that over. So my arrows have to point the other way because we're thinking about pushing data this way over these three sets of arguments. And they're basically applying into position 1, 2, and 3. So this is an applicative, right? And then it generates out for me every possible combination of those. And so they're just sort of laid out here in that way. So this is sort of like your hello world for applicatives in Haskell. The arrows pointing gives you a sense of the data flow, but sometimes it's like here, it's a little bit awkward because it's not that you're piping a single function or a single bit of data, you're piping multiple bits of data, which would be unusual, but we're still plugging into that intuition around pipes because pipes are everywhere in Elixir. So Elixir prefers what's sometimes called diagrammatic ordering, so that you can write it out like a diagram like this, right? Pipes are awesome. I love pipes. I want pipes in more languages, right? So we kept telling people we're just giving pipes superpowers. So this is a map, right? So we've taken a single bit of data and now we've extended it to work on collections. And instead of having a vertical bar, we have a little squiggly tilde, and now suddenly it works on collections. And the rest of your function is the same. So you could still write pipe enum.map on each of these, but sometimes it's just convenient to just have, you can read it really quickly. Tilde means this. The downside of using operators for this is that there's a set number of operators in Elixir. So you're going to conflict with some other libraries sometimes. So we had to make sure that we could turn those off at import time as well. So there's an option to enable operators or not. And all of these are automatically curried, by the way. So that's how it pulls in from Quark. All of this stuff becomes curried out of the box. Operators follow the same flow as pipes. So this is, you know, the top in this example, 1, 2, 3 is piping over that function, but you don't end up thinking about it that way in Elixir like you would in Haskell, right? We're now thinking about this as data moving around. And we added basically more arrows to show that, or so if you see in this bottom left, the number of angle brackets basically implies how powerful that is. So we have map, you know, apply is the standard one, then we add a tilde, this becomes map, and then we have the applicative app and chain, which is basically monadic bind. At the bottom, we actually have a taller hierarchy than in Haskell. We also included arrows, which I mentioned before, I think were criminally underused because people want to do this data flow stuff. So you can write out this diagram and then just express it as compositions of functions and fan outs and unsplits and all of this stuff. And then I've actually did a project where we baked this down into Broadway. I'm not sure if Broadway is still the main library for this or not, but so that we could describe just the shape that we wanted and then actually have it be run performantly in Elixir. So Functor Tower, these are abstractions, they're well principled. The purpose of abstraction is not to be confusing, but to be really, really precise about what you're trying to do and to have it be understandable to somebody who knows these idioms. So here's the most of what ended up in Witchcraft. So there's a bunch of hierarchy in here, and this is where we're using TypeClass to fill these out. And we're going to look mostly at this functor hierarchy, the thing that's outlined in this in that box. So functor, this is map. Most people are pretty familiar with this one. Works as you'd expect if you're coming from Elixir, enum.map and enum.into. So enum.map gets you down to a list with the elements mapped over, and then into, you have to turn that list back into the shape that you want. This does that for you automatically, and in some cases more performantly. Apply, we had to, this one was really awkward with the data flow because you're not often just piping a single thing, you're piping multiple things, right? So this embellishes function application, and we had to, based on the argument order, have convey and app and a bunch of these different things. Apply is already a function, so we weren't able to reuse that word. A bit challenging. Chain, which is just below monad, gives you this pipe operator. So this is essentially monadic bind through here, and it also does, just like with functor, you always stay inside that same data type. And so we're using Algae here to make sure that we know which data types we're going to end up in. Yeah, it just flows through with this binding action. So if you're using the actual bind operator in Haskell, it's basically chain. And then do notation. So do notation lets you take this version on the top right and then make it look like this with these left pointed arrows at the bottom, where you're always just bringing values back in. And if you end up at in this case with the maybe, if any of them are a nothing, you'll get kicked out and dropped down to the bottom. And so we could actually, with the operators and the facilities offered in Elixir, we were able to create full-on do notation. You just have to say either chain or monad at the beginning. If you can imply if you're willing to actually write out just at each step, you can do it directly. If you want return, you would say chain just or monad just do. And now you can also put return along in it, which looks a whole lot like this. So here I have monad list. So I'm saying I'm in the list monad. I'm going to pull out of nouns, each of these nouns, adjectives, verbs, and reactions, and then return this Mad Lib version. And then we're going to generate out the version on the right. So this is, again, sort of like a hello world version of the monadic style on lists in Haskell, just expressed in Witchcraft. And so we actually had, like, again, other than having to say which monad you're in because of how the type system is just missing features, at least today, though now they've added some stuff to the AST that would have made this easier. You get the full, very, very close to what Haskell has in terms of syntax. And the implementation of this actually turns out to be really simple. This is the entire do notation implementation. So we're operating on raw AST here, but we have left pointing arrow, and each individual line then gets the bind operator, the chain operator in between. So it's actually not that much code to do it. Just as an example, for those of you that are familiar with this style, here's the writer monad. Looks, again, a lot like Haskell, where we're writing into this list, and we're returning, or into this tuple. And yeah, we actually used this for some logging in production as well. Yeah, another example is extending that previous one. You see logs down around the middle. We have pipes and then also binds in the middle, like chains in the middle. And so that gives you this ability to interleave the two. Now you're obviously working at different semantic levels when you're doing this, and you're not forced to stay inside of the monad, right? Because of how the type system works, but it actually ends up being relatively natural in feel. So lessons learned along the way. Build it and they will come. I didn't expect people to be as interested in this project as they ended up being. or for it to get as much production use as it did. People became interested in it over time, and especially projects that last for longer amounts of time. If you're writing a library, if it's just been around for a few years, people might be interested in it, or you give a conference talk about it. I gave a keynote at Elixir London, now called Codebeam, in London, and so that had a lot more use all of a sudden, and a lot of people that wanted to maintain it and get involved. But as a solo maintainer at the time, this was a lot of work, right? And so maintainer burnout is absolutely a thing, 100%. Something I've learned since then on other projects is to get people involved in it that might be interested in it, or even that want to learn, even if they're not a quote unquote expert in the thing, from day one. And like, hand off as much credit to them as you possibly can, right? It's not about having the glory yourself. It's about getting other people involved because you want the project to exist and it must be larger than you. I left this too long in Witchcraft. By the time a bunch of people wanted to help maintain it, I was just not there to really help onboard them into the project anymore. Prior art sections and readmes, strong recommend, right? At the bottom, just say, hey, here's other projects that are like this. Maybe you'd find those interesting too, right? If we want this style to happen, there should be multiple competing, not even competing approaches, there should be multiple approaches. Call up the other people that are doing this stuff, right? Talk to them about their approach. We're all in this together. We want more of this style to happen, right? Haskell always said that they're about avoiding success at all costs, which has the two interpretations, like avoid being successful, right? But also, and stay in the academic track. But more importantly, avoid being successful at all costs and diluting the concept, right? We want to be, want these things to find their way into other ecosystems, into other areas. We want to help support other people doing this. And that's something that, as a maintainer, I just failed to do early on. All things come down to humans and governance, right? It's something that I've learned along the way. The other thing to note is that maintainership is different as a project evolves. So we actually took Witchcraft very quickly from something that is quite visible and like, using it as a teaching tool and like really innovating on how to bring these things into a new ecosystem. And then over time, it just sort of fades into the background of like, yeah, it's a dependency, right? And different people fall into different parts of this spectrum. And my career has basically been moving towards the left, right? So towards invention over time. And when you have somebody who's more on the invention side, they get bored. They don't want to write, 100 million benchmarks. We did in Witchcraft because it was the right thing to do. But this is also part of why the maintainership fell off a little bit. The other thing to note is that the further to the right you move on this spectrum, the more money there typically is for maintainership and sponsorship. So getting people involved early on that can then take it into companies that want to support it in the long term. Evan, the creator of Elm, talks a lot about this as well. So I'd recommend looking at his Strange Loop talk from 2 years ago, I think, about this as well. And also what this then enables is once you have that thing as a really solid base, like let's say, you have whatever TypeClass is now really solid, that enables you now to go and do more innovative work again and bring in those people that are more interested in the invention side or the bringing things out of pure ideas into and popularizing them, right? And then it can, this cycle can continue over time and we can just get better and better, cooler tools. Also, final thing, if I were to approach this these days, I actually would have just put a type system into Elixir. There's this great paper, Type Systems as Macros, implements a system or shows you how to implement a system called Turnstile. I would have just put Turnstile in there now. My tastes have really dragged over into co-effect systems and capability systems. If you're not familiar with capabilities, I strongly recommend functional programming people to read Robust Composition by Mark Miller, especially if you work with the actor model. They are such an extension of the functional way of thinking, especially in a distributed context. So I would, and they have a very close connection to co-effect systems and types. right? You won't find that in robust composition, but like it becomes very apparent, I think. And I would say branding over time has become even more and more important. One of the things that gave us a boost for Witchcraft is that we had a cute logo, right? I worked at a company that had a lot of designers in it, and one of them was like, yeah, I mocked this up for you over the weekend. Do you want me to make it properly? I was like, sure. And that makes people think that it's like, more of a serious thing. And I would say that that's even more important today than it used to be. So anyway, that's the whole presentation. Thank you very much for letting me ramble about my 10 years of writing Witchcraft.
Thank you very much. Very interesting. Thank you very much, Brooklyn. And a very ambitious project also, making this happening. I mean, it's not just, I'm going to take this part. This whole part I'm going to bring into another language and build my own system. It's very ambitious. I mean, of course, I think it's, very ambitious. Still, we don't have any questions right now in the chat. However, we have one, like, shout out, like, super cool to hear about the project. We also had a shout out, like, totally recognize this maintainer burnout. You start something up and then all of a sudden you're like everywhere helping people and then you get burned out. However, I have a question. It's like, is Witchcraft used today in production? Are companies using it, or is it?
Yeah, so I'm not super sure how widely it's used today. I was looking at the stats while I was building this talk. It's still getting a couple dozen downloads a week, so somebody's using it somewhere. We did use it quite a lot in production. 2016, 2017, 2018, 2019 got a fair bit of use. There was sort of a small community that were using it and putting in things and having success with this. I was mostly you see issues in GitHub, but then I'd go to conferences and people would, that's usually where you hear about the positive sides of people stuff. And actually a few people also gave talks about using at other conferences, their use of Witchcraft in projects and basically trying to encourage people to use it. So I assume that it was a good experience for them. But I don't know of any off the top of my head today that are using it in like a really heavy way. But it used to, at least.
You're working with Rust today? Are you looking into porting or doing libs in Rust? Similar to Witchcraft? Or are you already on it, maybe?
The last 5 years, I was running a very R&D focused company as the CTO. We built on top of Haskell, but we found that Haskell on the back end and for things like CLI tools and whatnot. And I would say actually that was a really great experience overall. The tooling in Haskell, not always the best, right? But like the actual writing the language, amazing. And we were able to hire people that were really passionate about Haskell. So the hiring story was like unparalleled. We had people asking us constantly, like inbound, which unheard of, right? It was like we didn't need recruiters or anything, right? It's amazing. And then Elm on the front end. But over time, we found we were writing more and more TypeScript because people wanted to consume it in, we're writing SDKs, they need to consume it in their own apps. And we started writing a lot of WebAssembly. And the primary language for WebAssembly is Rust. Rust has a lot of, obviously it's not a functional language per se, it's multi-paradigm, but it's, it's like the first class language for WASM. It is strongly typed. It gives you, like the borrow checker is, I'd love to have a borrow checker in more languages. It's once you learn how to actually use it, but you can also write in a very functional style, right? Maps and reduces and all of this stuff. They do encourage you to use, right? They call it a functional style. It's like functional-ish, right? Because you're always in IO. But yeah, mostly Rust these days. There are a couple projects porting things in to Rust, and they have macros as well. But they the core language is missing a few things. They don't have higher kind of types, for example. As soon as they ship higher kind of types, there will absolutely be monads in Rust, right? And you kind of fake it today, like in a similar way that we do with Witchcraft, but it's so far out of the idioms in what is already quite a large, complex language. Unlike Elixir, which is, I would say, actually a fairly large language, but really focused on developer experience. Like, if I wanted to say what the thesis of Elixir is let's make this really friendly. That gives me the headroom, right, for complexity to add monads into it. Rust, it's very complex already, right? So I don't know if people would necessarily want all that extra complexity in today. So no current plans, but there's some stuff in the standard library that is intentionally very functional already.
Yep. Final question from the chat. It's like, you seem to be into statically typed languages. Have you looked at Idris and taking it further with types?
Yes. So we did a whole session at the Vancouver Functional Programming Meetup about Idris. Idris 1, we implemented I implemented and showed off to the meetup a little web server. Idris 2, I haven't played with as much. So let me take a step back. I really, really, really love dependently typed languages. I think it's a really interesting approach. Idris 1 had this whole tactics language. In addition, it was a little bit in some places like you've got a lot of power, but it was somewhat difficult to work with. Idris 2, I haven't played with as much. Like, I've looked at it, but not as much. I was involved in a conference last year called Causal Islands that actually brought Edwin out to talk about Idris 2. So chatted with him about that last year a little bit, and it was super, like, similar to this, right? Learning his lessons over time of like what he would have done differently and like how this all fits together. Super interesting. The language that I'm most interested keeping an eye on in this space, though I don't think it's like explicitly like dependently typed in the same way, is verse. So I'm anytime something about verse comes out, which is Simon Peyton-Jones is working on this right now for Epic. I just voraciously read whatever I can as soon as they announce anything. So that's and because it's coming directly in a production system with some really, really innovative features and trying to make it familiar to people coming from C#. It's fascinating.
Cool. I will for sure check it out now. I haven't heard of it before, actually. I will check out verse now. Again, thank you very much, Brooklyn. Thank you for your presentation. And thanks for coming on and presenting. Very interesting. The audience loved it. Me too.